Okay, here we have another building, and this is for what was this project? Let's see here. Great Neck Town Hall. All right, let's start. Hopefully, this is gonna be a fast one. All right, we got some column footings, so I want to start with the column footings. I don't know. I already uploaded all the drawings, but I didn't do anything else. Let's see where is the column footing schedule. It's here. I just want to set the scale on this page so I can do some markups and split the right. So I have my column footing schedule at the right side, and the left side I have to activate this window to be able to work on it. And the left side I have my foundation plan. And let's start with the F1 footing is the smallest one. F1. First I want to change the group name to column footings, since I'm going to start with the column footings. Column footings. Save. Now we created the group column footings, and we started with the count elements. First element is the F1 footing, F-1. It's not rectangular, it is square, and I like to use orange color for column footings, and it shows 6 feet and 1 foot 6 is the thickness. 6 feet sides and 1 foot 6. You can write like this, or you can write 1 foot 6 with the dash, or you can even write with the without dash. It turns it to the same. And the elevation, this is the for the 3D feature. If you want to use 3D feature, you gotta put the elevation, so in the 3D space it puts on the right elevation each footing. And this is concrete element for sure. I didn't check the concrete PSI. We can get back to it for now. And I see 90-degree hooks in the rebar. We were gonna come back to that. And right now I just need the elevation of the footing. I see it says 14.8. Is that the top of footing, bottom of footing? What is it? All right, here. Now we're working with the tight space here. Let's open this up. All right. All project elevations are measured from base plane 0, That's mean top of slab is 0. That corresponds 8560. Good to know. F indicates the spread footing. Let's go to the next one. Dimensions and location architecture. All bottom of footing elevations to be coordinated in field and given for estimated purpose only. All bottom of footing elevations, see architecture drawings. Oh, here you go. All bottom of footing elevations shown as this. So these are bottom of footing elevations. And it doesn't say what's the bottom of footing or elevation for the column footings, but it does say for continuous footings. If the continuous footings and the column footings are in this are same thickness, then both will have the same bottom of footing elevations. But if not, then we will have step. But for now, I'm gonna use this minus 14.8 elevation, minus 14 feet 8. Let's look like basement here. Okay, if the base plane elevation is 0, this has to be basement. Let's start with this. We'll fix if we are wrong about the bottom of footing elevations, because it's not provided here. All right, and this one is minus 15, but I won't change. I will edit it in the right panel here. This one is 14/8. Okay, so far so good. 14/8. Looks like all of them 14/8. Only one is 15, 4-inch difference. Okay, we go here, edit. We will see it's 14/8. We make this minus 15 feet, and we're done. When we come back to it, it's changed already. Okay, now we got the F1 footings and the reinforcing for the hooked at ends. It says here already. We gotta add the reinforcer for this. And it is pretty simple since both directions is square and the both directions gets 10 number 5. We just type 10 and select the rebar size and select the shape, the one with the 90-degree hook, and we just simply click A, tab, A, tab, A, tab, and we got it. Now this is only one way, and when we multiply this, it's gonna be both ways, each way. And it's not top and bottom, only one math. Save. We're done with the F1 footing. Now we move to the F2 footings. Click F, type F2, F-2. We got square. I can lock the color here. Column footings is our group, and the 7 feet. And the 1'6" is the thickness. And the bottom of footing, see, here's the thing. See, this the footing thickness on the F4 is 2 feet and F5 is 2'6". Let's take a look at this. F4, does it affect? Minus 15. Okay. They fixed it. Top of footing elevations we have to make sure are the same. So formwork for the walls sits on the level. We are not creating any step in between here. Let me try to, actually let's do this and then I will explain. F2, I have minus 15 here. And minus 15 here. So minus 15 bottom of footing elevations. Okay, we got just 2 of them, I believe. That's F3, this is F2. Minus 15, and let's add the rebar. This is square as well, and it has 10 number 6. Type 10, select the rebar size and shape, and just keep pressing A and tab. And multiply by 2 because it's each way. Save. And yeah, what I was going to explain is if the footing is, let's say, if the bottom of footing elevations are the same, this is the bottom of footing, and let's say this is the continuous footings here. This actually ends here, right? Continuous footings end here, and continuous from here. Up to here, and then another footing. And let's get a square shape, rectangular shape. And this, I'm trying to give you side elevation for this continuous footings and footings here. And thickness of this F5, this footing, thickness of this, what is the M2 footing? Sorry. Let's say this is thicker. If this is the case, then your formwork for the walls, you're creating step. We don't want to do this. What we want to do is to be easy constructability. We want to make like this top of footings the same elevation as the continue with this continuous footings. So this way you can put your formwork for the walls faster. If you create a step, that will be a lot harder to set the formwork. Let's move on. F3. F-3. Sorry. F3 is 8 feet and 1 foot 6 is the thickness. And we use minus 15 for the F3 since this guy says minus 15. And make sure it's 1 foot 6 is the thickness. Okay. F3. Do we have any more F3s? No. And let's add the rebar for this F3. It has 12 number 6. 12 number 6 with the hook. 90-degree hook. Times 2 each way. And type A each way. Next will be F-4. F4 is 10 feet footings. And the thickness is 2 feet. F4, it says minus 15.6. Minus 15.6. That's F5. That's F5. We don't have any other F4. So let's add the rebar for the F4. It has 10 number 7 with the hook. 10 number 7 with the hook. Times 2 because each way. Next will be F5 footing. F-5. And the F5 is 11 feet square. And it has 2 foot 6 thickness. And the bottom elevation for the F5 we have, it doesn't give here. This is the only one has a problem actually, because it's not providing bottom of footing elevation, and the thickness of the footing is different. Let's use, okay, this one is different too. Let's use 14.8 for now. 14 feet 8. Because it's given 14 feet 8. And this one is 15.6 and this one is 17.6. I have to change this by editing. Minus 15.6. Minus 15.6. And then edit minus 17.6. Okay, pretty much F5, and I'm just curious about this bottom of footing elevations. And one more thing, we have to check the concrete PSI if there's any notes on these drawings. Let's see, F300. Usually they are at the first page, but this guy wants at the last page. Alright, structures, where is the concrete? Submittals, sharp drawing, sheet index. Structural notes. Welding, fabrication, fabricated connector design. I just need concrete. Brazing. Okay, reinforced masonry. Structural masonry. All masonry walls shall be anchored to the floor slab or curve with those number 5 16" on center. This is an important note, we can keep it. Vertical reinforcing shell with splice 50 30 bar diameter, that's okay. Pierce shell with truss type. There you go. Concrete nose at the end. This job is strange. Okay, have a minimum 28-day compressive stretch as shown on the concrete material schedule. So there's a concrete material schedule, it's right here. Okay, it's 5,000 psi, slab on grade and slab on deck is 4,000 psi. So we made a mistake by not looking at this at the beginning. We just need to change this. Once we change this, all the elevations we're gonna lose it as well, because this is the main edit panel. But that was our second question about the bottom of footing elevations. We have to figure that out as well. 5,000, we make all of them 5,000 psi. All right, now we lost the elevation changes on these. We gotta change this to be sure this is minus 15, and be sure about this one as well. That was on the 1, 14.8, 14.8. This is all good, and this one is minus 15. It says here. So only thing we missing here. Let's figure this out. Okay, cellar slab is rectangle. Okay, minus 12 foot 7.5 inch top of the slab. Let's look for detail I was looking for. This is the detail I'm looking for. And this gives me the, doesn't give me any dimensions, but that's okay. We know the bottom of footing elevation minus 15.6. And top of slab is minus 12 7.5. What's the slab thickness? You think it's giving us? We are not that lucky. Hey, elevation is here, 5 inches. So we have minus 12 7.5. Let's see if this calculator works. Minus 15 foot 6 inches. It doesn't know minus. Okay, we say deduct from minus 12 feet 7.5 inch. Calculate. So 2 foot 10.5. 2 foot 10.5 is the difference from bottom to this top elevation, and the slab is footing thickness is for F4. What was the footing thickness for F4? Is 1 foot, no, 2 foot. So 10.5 inch difference. 10.5 inch difference, and the slab is 5 inch. So 5.5 inch hunch. For F4, let's say here, F4 has 5.5 inch hunch. Okay, let's see, the F5 is the same, and the thickness for the F5 is 2 foot 6 actually. So gonna be 6-inch lead. It doesn't really work for this F5. We have this kind of problems. Let me try to explain a little more here. Okay. Actually, let's get the rectangle. Side elevation for F5, right? This is F5. Bottom elevation is minus 15.6. And the top elevation thickness is 2'6". 2'6", so it's minus 13 is the top. And the slab is here at minus 12'7.5". And the slab thickness is 5 inches. And we give the 5-inch at the 5-inch here, it comes here. Minus 13 feet. Yeah, 13 feet. When you have 5 inches, 13.5. 0.5. So on this footing, we don't have hunch. Actually, it's sticking up 1/2 inch. This elevation questionable when we're doing the job. Right now, we're doing the estimation. We're just gonna go with it. Okay, but the way it shows, the footing elevations are walking. And I want to see what the thickness of this one F421 footing. Let's set a scale for this so we can make some marks on it. Section 1, so 1'6". So that's mean footing thicknesses are the same as column footing thicknesses, wall footing thicknesses. The thing on this one, I want to make sure the top elevation of the column footings are the same as the continuous footings. So I'm just going to lower this one to the correct elevation. F5 is 2'6", so 14.8. I'm going to add 2'6" to 14.8. So 15.17.2. I'm just going to make this minus 17 feet 2. Okay. And this one added, actually we had this wrong. Not the plus. Let's do minus, we're supposed to put minus elevation on minus 15.6. Let's change this again. Minus 17 feet 2. And minus 17.6. Now we're good with the elevations. We have to check the same thing on this. Actually, I could show you on the 3D. We do that when we come back to the continuous footings. Let's do N1. Which one is N1? N1 is this guy. And bottom of footing is minus 19.6. Okay, and the N1 is 2 foot thick. And these gonna be mat slabs. N1. Come on. M-1 mat slabs. And thickness is 24 inch mat slab reinforced. Okay, this is, I'm gonna do red. 24 inches the thickness, and the bottom elevation is given as minus 19.6. and 5000 psi. Don't forget that. And a new group for mat slabs. When do I create groups? When I see any concrete element with, I'm gonna categorize as different price. When I'm pricing it, if I'm gonna put a different price for one element, that's mean that element has to be in the different group. I can't keep them the same as column footings. It's a mat slab. Okay, we're good here. This area, because it says here C plan for the dimensions, so I don't know the sizes. I just go around it. Okay, 5F201, 200, sorry, it's here. Mat slab reinforcing. And it says 24-inch thick mat slab with the number 7, 12-inch on center each way top and bottom. I'll add a rebar. Here on the areas when you're adding a rebar, let's take a look at this area. This area, it will show here. Take a look. It's 200 for 13.62 square feet. Okay. But it is 14 by 15 foot 3. So to be able to come up the automatic way to add rebar to this, what we did is we took the square root of 213 feet, which comes to 14 feet by 7. So you can basically add, it already tell you how many counts. You can just basically do this times 2, and you can hook this out. Instead of 14 by 15.3, it calculates it as square. Instead of rectangle shape, we make a square, and we can do each way, and it's simple math. But you can also change these dimensions to make it exact. If you're gonna cut rebar or something, you can do 14. You can change this to 14 feet, and you can change to 15.3 to be able to get it. Then you have to do twice. You gotta do one way first and the other way second. Right now I'm doing as square. I assuming that square 14 feet 7 inch 738 square. So I just say each way, top and bottom, actually top and bottom. So I have to multiply this 4 because 4 layers we have here, and we're done with this. Okay, we're going to left side. I mean, what I see here, this mean is rebar not added on this one. We added rebar on this blacks, all the blacks. This one we forgot to add rebar. Let's add it. F5 has 14, number 7. So we have some visual guidelines. You can catch some clues, 14, number 7 times 2. And we need to change the shape each way. This is the simplest way to add the rebar. I don't know any other software can do this. All right, if you know, let me know. All right, let's go to M2. Now we have the, they don't have M2, they have M1, M1, but you can assume this M2 and the same reinforcing. So it says the same thickness, but it has different elevation. But what I will do, I will create another element. M2. M2, and I will say this is 24-inch mat slab, reinforced. 2 feet, and the elevation is different only here is minus 15. I didn't have to, I could have just continued just pressing this and it should get back here and change the bottom elevation from the edit, but I'm not doing that right now. I'm just do this M2, and what I can do is I can just basically copy the reinforcing from here and paste here. When we look at it, so it's 12 by 12 square. We're changing it, assuming it's 1238 by 1238 square, and that gives you 13 bars. Number 7, shape is okay, dimension is right there, times 4. So everything comes, the rebar applied to this converts to this one, applies everything. And now M3, where is M3? M3 is this big guy, and the thickness of M3 is 2 foot. Same thing, and the reinforcing is the same. We could have done same thing, but on this one, this is longer one way, so we need to consider lap splice on this direction. Let's look at this. M3 24-inch mat slab reinforced again. Two foot is the thickness, and the bottom of footing elevation is 15.5. See, this one given 15.5. Nice. Minus 15 foot, 5 inches, 5,000 psi. All right. Now, number 7, 12 inch on center each weight, top and bottom, right? That's what we have. Yeah, see, it says top and bottom. On the M4, bottom hooked at ends, it says. We have to make everything with the hook. Alright, now, not show rebar, add rebar, we'll do add rebar. Okay, so when we keep the stock length, it will give us 21 feet. Stock length is 30 feet. So this assumption doesn't create lap splice, but we definitely need lap splice for 43 feet long mat slab. So I will use the dimension here. We'll do a little bit of work, but that's okay to get the accurate result. So it does automatically use the other dimension and the same square footage area. So what I'm gonna do is I'm just gonna do the first, I'm assuming using 30 feet stock length rebar. So the length of the rebar will be placed on this direction, 43 feet 9.5 inches. This is correct. But total length will be 45 feet. This is for the bottom bars because this includes the lap splice. So first bar I'm placing is this direction. Let's do a line. I'm doing this. Okay. And the bottom. So this is long way bottom. So we'll have an 11, no, number 3, not number 3, number 7s. There you go. 11 number 7s with the hook. Okay, 11 number 7s. Shape 2 is the one with the hook, and the total length will be 50 foot 2 inches. Long way bottom, we got it. Now we're gonna do the same thing for the 3 feet 9.5 inches. I want to do the top bar. Top, because lip splice changes for the top bars, and the shape is this. Again, same direction, top bar, long way, top. 7 new. Now for the short way, what does anyway, for the short way, this direction, since it doesn't require any lap, I can use automated thing, automated assumptions. So I will say for the actually, let's do it right. I cannot use it for 3 feet. I just can use twice because top and bottom will be the same, because no lap splice required. So top bar and the bottom bar doesn't require any lap splice. It will be the same length. Number 7 with the hooks. Now I will say times 2 short way, top and bottom. All right. On this one, they use the number 6s, and the thickness is 1 foot 6. And 4, 18-inch mat slab. 18-inch, and the bottom elevation is 14 feet 11 minus 14 feet 11 inches. And the reinforcing, we already said what was it, number 6 like yeah, number 6 is with the hook. We can use assumed dimensions and select this times 4 each way, top and bottom. So far so good. Let's take a look what we created. As you can see, these are the perimeter footings, these are interior footings, and this is for the elevator. That's why it's deeper. This one is elevator, that's why it's deeper. Let's go back and let's create the continuous footings for the walls. And it has some grade beams here, GB1, GB2. I don't see any grade beam mark. It's 1 foot 2 feet, 1 foot 4, 2 feet, 2 feet, 2 feet. Maybe in the different drawing. Maybe on the next page we'll see it. Okay, now let's concentrate on what we're doing here. On the footings, we're gonna get we'll be doing the continuous footings for the walls. 1F0201. Let's open this here. 2F0201. We already got that. 5F0201 showing the column footing. 1F0201 again. 5 here. 1 and the 5 showing the top. See, these are the grade beams at the second level. And 1 here, 4 here. 4 is showing top elevation as well. And again, 1 and 1. So our detail is 1. which is 4 foot 8 footing with 1 foot 6 thickness. And I will use, let's select the page we're gonna do the takeoff. And I will call this wall footing. Wall footing. And there's only one type of wall footing. I don't need to call anything else. And I will call this wall footings. This is the wall footings group. 4 foot 8 is the width, as given here. 1 foot 6 is the thickness. And the bottom elevation given is minus 14.8. And this is 5,000 psi. And because dirt is brown, I like to use brown. Alright, let's create this. This is too much. There's GB1 showing, yeah. And the GB2 here. Okay, those are at the top, I believe. Okay. Should we stop this right here? Or should we continue? I mean, these footings are big. If the footings was small, I was gonna continue, but here these are big. We can adjust these little things. Just for now, keep going. And see, it's wider here for some reason. I'm just gonna go to the end. We'll measure that. Okay, let's give it trouble now. And the reinforcing, we will have problem when you're doing this piece by piece footings, because reinforcing for the footing will continue through the column footings. It has to. I'm just lapping here because it's coming up. Let's continue again. When you do close, actually I'm gonna delete this. When you do very close clicks, 3D sometimes gives you different shapes. And let's just adjust this our takeoff, make it beautiful. It doesn't really fit in there. It's 4 foot 8, right? So this is 4 foot 8. Let's check our scale since. Is it too late already? Yeah, 8'3" is perfect. Somebody messed up on the scale, I guess. Alright, anyway, we make it what we can do best. Alright, now we're gonna have the reinforcing for this guy. And the reinforcing is 6 number 5 continuous. Our continuous bars, we're gonna continue, and the short bars, and let's add them up. Okay, here's the thing. We got 6 bars. It shows already the length wise, which is 180 feet. So we don't need to change anything up there. And the bottom bars, we just do 6 number fives. But this is not including all these column footings. But the way it works is you have to, at the job site, that's how rebar shop drawings done. We have to continue through the column footings. So we need a full length dimension. This way is 60 feet. I'm just trying to, actually we can count this. F1 footing was 5 feet. Let's do a better job. What I'm gonna do is I'm just gonna get a reference linear item, and here I'm gonna add lap splice, but not right now. I'm gonna do that there. I'm just doing this as a reference line. I will delete this. So this reference line is showing the length of the rebar. That's 276 feet. Okay, now add rebar here. 6, number 5. And then number 4, 2 for 3, 276 feet we said. So I'm gonna add 5 feet more for the development length into this mat slabs. 276, if I say 275, that's plus 5 is 280. Let's say 285 feet. And it calculates all the lap splices. And this is only continuous bars. So we got 285, 7 new. Now we changing the direction. Now short way bars. Now we'll do 285 feet. Now they say 8-inch on center actually. We need to calculate what's the 8-inch on center. 285 divided by 0.66 is the decimal of 8 inches. So 432 bars. 432 number 5s, U shape. This is short way. And basically we're done. Let's take a look at our, we need to refresh this grouping. Okay, see this was the reference length for the object to figure out the length of the rebar. We just need to delete that one, which is this one, remove. And refresh this. Only thing I'm missing here is this piece, because this was thicker footing, and we were just gonna copy the reinforcing there. And this is WF, another WF, WF wider, WFW. And the width is, we're just gonna scale from the drawing. It is bigger, and the thickness is the same, 5000 psi, and then minus 14.8 is the bottom of footing. I guess the middle is here. Perfect. We already include this, but I'm just gonna get it. How long is this? Like 4 feet, right? You have to be careful what you're doing here. Continuous footings. This one, see, since we changed this element when we're copying, If we didn't change it, it will calculate it automatically. But right now we changed it, so it's not gonna calculate. You need to put automatic value A. So when you put the automatic value A and copy to another element, it calculates the new element's length. So here we gotta change. See this? We gotta do not here. Sorry. This is gonna be 8-inch, and that's it. Now we go with all the column footings, and this is our concrete elements, column footings and continuous footings actually. Yeah, let's take a look at here. Now, what we create is column footings. All column footings are in the same group, and we got the total cubic yard of 70 cubic yard. It adds up, so I can price this at the same price because they all column footings, and the mat slabs the same in the same group, and I have the concrete volume. I can price all of this at the same price. The same thing as wall footings. All the wall footings are in the same group. And let's take a look at the rebar. So far we got 18,000 pounds, and all the rebar listed here. Let's go back. Now we're gonna start with the walls for the elevator pit, which is 5F0200. It has 1 foot hunch, and they just could have put here dimension, and we gotta do all the work. Actually, it says here elevator pit minus 21. If this elevator pit at the top is, if this is the top of slab, then this is wrong, because M1 footing was 2 foot, so this is supposed to be minus 23. Minus 21 plus 2 minus 23. This elevation doesn't make sense at all. But what we're gonna do is, we're gonna assume this is the bottom of footing, not this. And the top of footing will be minus 19. Let's change that. Minus 21. Okay, you see, if this is the top of slab, is bottom of footing can't be higher than top of footing. I mean, everybody can see that. Okay, now what's the height of the walls? We said 21 here, so top of slab is minus top of mat slab. We didn't select this. Top of mat slab is minus 19 feet. So we got here 12 foot 7, call it 36 foot 5, 6 foot 4.5 inches. Say, call it 6 foot 5 walls. And the walls, it gives number 612 inch on center each way, and we have a dowel going here, and number goes into the mat slab. Alright, we're gonna do dowel and vertical together, number 6 bars each face, and we'll do the horizontal bars, and we'll add this top slab dowel. It doesn't call for it, what size, but we'll do number 6 the same. Okay, thickness of walls are shown different. It has piers. This one, I believe, 1 foot wall. We don't have that information. And these are 1 foot 6 walls. I don't know why they don't do 1 foot, but I will do all of them 1 foot 6. Okay, here 18. I always put the thickness of the walls. 18 walls, 6 foot 5. And I don't deduct for the hunch at the top. That's how I do elevator pits. It is really very minor concrete. You will need that extra. And this is 18 inches. The width is the 18 inches and the height is at 6 foot 5.5, 4.5. I call it 5. And the bottom elevation we called, this is minus 19, bottom of the wall, which is top of slab, minus 19. And for the walls, I pick green tones. And I will start from here. A little bit back, maybe here. This is okay. Let's take a look here. See, this is our elevator pit walls. Alright, let's add the rebar. I want to start with the horizontal bars. Horizontal bars doesn't go side by side, it goes this range. And the range will be in the Z direction, one on top of another one. And we consider the horizontal bars as top bars and size of the rebar 6. So height of the wall is 6 foot 5, so you need 7 bars. And horizontal direction, total length is this. Only thing is each face, one on this face, one on that face. So horizontal each face. We'll have the same one, same thing again, but this time it's gonna be corner bars. And that's all you need. Okay, now this will be times 2 because of each face, right? But it has 4 corners, so it's gonna be times 8. Corner bars each face. Now we'll do vertical bars, and direction will be X direction to the length, 33 feet. So number 6, 12 inches on 33 here. Number 6, we're doing double and vertical, standard to get the bottom, and this will be Z direction plus the thickness of the mat slab. Thickness of the mat slab is 2 feet, 6 foot 5 here, so 8 foot 5. And this will be each face. Double and vertical each face. And what we're missing this slab dowel. Again, Z direction, X, number 6. I'll say U bar, let's say again, and LL. And this is only one, and it's all around. Slab dowels. We're done for the reinforcing for the walls. We can add these piers since we are here. We say piers. They are square, but we need to create new group piers. I like red color for the piers. Again, I'll change the tone, darker red, lighter red. Let's make them pink. Okay, it says 2 foot. When you type like this without inches, it converts it to inches. And the height will be the same, 6 foot 5. And the bottom elevation we said minus 19 feet for the elevator pit, we wrote it here, and 5000 psi. Okay, and we put it one here and another one here, and let's add the rebar for this. And verticals, I want to add the verticals first. We know the count of it, so we don't really need the x or y dimension at the direction. It says 14 number 7, 14 number 7, and will be double and vertical, right? So standard here at the bottom, and 6'5" is the height, z direction, and we're gonna add the thickness of the footing is the mat slab is 2 feet, so 8'5", 8'5". This verticals. Then save and new. Now I want to add the ties. When you do the ties, only pay attention to this. Change the range to Z because it's going to be one on another. So Z direction, and the size are 4, 12 inch on center, so 7 bars. We click here T for the ties. All we have to do is keep pressing A. It gives you automatically all the values you needed, and call this ties. Save. That's about it. We're basically done with the most part of the foundation. See, we actually double dipping here because footings goes into the walls, but these little bump outs so hard to do. We need a little bit of this extra concrete. Okay, what else we doing here? We gotta do the walls and then the other piece. Okay, let's take a look at the wall details again. Before I do that, I just wanna pause how much I am into this video already. I don't know. Let me see. We're already in 1 hour. Let me pause for a second, and I'm gonna come back. All right, let's go back to what we have. Now, you can bring this down. Yeah. Now we're gonna do the walls. For the walls, we're looking at this drawing. So bottom of footing elevation is minus 14.8. That's right there. Minus 14.8. So bottom of wall will be minus 13 feet 2. Top of wall is a couple inches below the deck elevation, but we'll go with 13 feet 2 for the wall heights. Thickness of the wall, we gotta look in the plan. I believe it's not given here, and in the plan 1'4" is the wall thickness. 1'4" here. Again here 1'4". All the walls look like 1'4". Yes, it is right here, and we'll assume same thing over here. So let's start the walls. Since all the walls are the same, walls 16-inch walls, the thickness of and the 13 feet 2. I will need this when I'm pricing. I will need these notes. It will be a lot quicker instead of looking at each item and call here walls. Okay, thickness is 16 inch, height is 13 feet 2, and bottom elevation is minus 13 feet 2. And I will take this same thickness. This is probably 1 foot wall here, but I will take it as same. See what I'm doing? Follow this line, little kinks here. Changing like here. Anyway, just go with here. For the estimation purpose, not a big deal, those things. I will continue here as well. This is gonna be big white pier. Stop it here, bring it from here. Okay. Now I got the walls. Any change in the reinforcing before we get into it? Number 5 horizontal, number 6 verticals. And this is the grade beam at the top. We got dowels here. Something going on here. At the glass facade, it is going higher. It looks like a curb on top of the grade beam. And the reinforcing is different too. So we actually didn't do a good job here. This has different reinforcing. I didn't pay enough attention, I believe. Alright, this is different. Section 2 is different. This wall at the pier, I'll take it straight. Okay, where's section 2? Section 2 applies here. I'm gonna delete this section. No, I did it wrong. See, it went to the other page. I gotta take this call. Alright, let's go back to where we have walls. So we know section 2 has different detail which applies to the front. You're gonna create different element for that. Okay, let's do the section 1 first. Add rebar. We'll do horizontal bars. We consider horizontal bars top, and it says number 5, 12 inch on center. Each face. Horizontal, each face. 7 new. Now we're doing the verticals. Verticals are number 6, 12 inch on center. Yeah, it is a hook at the top. So we do like this. Times 2 each face. Vertical each face. 7 new. C and X. Number 6. And the lap splice is 2'8" and plus another 1'6", 4'2". I'll call this 4'6" times 2 dowels each face. And top dowel is number 4, 36 inch on center. 36 inch on center is the spacing. Number 4, the U bar, and no, not A, and L, lap splice, that's what we need. And this is slab dowels. Save. Now we'll look at the 3D. We had the walls. As you can see, we got the walls. And these walls, we gotta take a look at again. Where are these walls? Okay, we continue the wrong wall here. That's why I love 3D. When you make a mistake, instead of continuing to taking off this wall, I continue this elevator wall. That's the beauty of the having 3D. You see your mistake right away. Alright, this is the one we're gonna continue. Okay. And the reinforcing we put in the wrong place either. I mean, see what we did here? Slab dowels, horizontal reinforcing, vertical each face, dowels each face, and another slab dowels, 1'9", 1'9". So this slab dowel belongs to elevator. I'm just gonna copy here. Let's take a look at this 299. This is verticals, 13.2, makes sense with the hook at the top, and horizontal each face, 14 bars each face, and these are slab dowels, 3 foot on center, and these are the regular dowels each face, 299 matches. So what I'm gonna do is I just need to delete these bars from here. See how we make easy mistakes. Now we're good. No matter how long you're doing this, you always make mistakes, and you just need clues to figure out. Okay, now we're gonna go to this guy. I'm gonna top of the curve. We don't know what's the top of the curve. Original drawings, architectures. Let's see what's going on there. This has to be top of curve elevation, maybe. Let's look. Okay. And we can easily see that detail will apply to this wall type W6, W7, and W6 again. This is okay. Here we're gonna look at this 3A200 and 18303. 3A200. Oh, this guy. 3A200. Okay, this is probably our curve height, or this, we'll see. And 313, right? Already forgot what was it. Doesn't show the section. Come on. 18303. Left side doesn't tell me the height of this. But for the estimating purpose, we know wall here, grade beam on top, and a curb on top. I'm gonna take this wall all the way up. This is a lot of work here. But how high should I take it? One way I can scale this drawing, or wasting time to look for the detail. It's not even 2 foot. Another curve here. So around the terrace or roof probably, I don't know. And might as well take a look at other things too, right? Stairs are synthetic stone threaded, steel support angle, stone threads, so no concrete there. 1/4 inch synthetic stone landing, quantities steel stair pan. It sits right on the steel. And these steps are penfill steps. These are concrete. These are not concrete. Some concrete, some not. Let's keep looking for the detail. Okay, that's not. Over here, I don't see it. Elevation. Different elevations. Interior elevation. Okay, it's ready. And what's going on here? Stone top, wood cap. I'd like to know what's going on there. And it's not giving me. Okay, we went to E drawing, so we go back and scale it. 303, we're gonna go to 302. 302, I believe. Not 303. Alright, I'll show you how to scale using Adobe. You just scale a dimension. This one is no. Okay, we can do this way too. 11 foot is 132.8 is 11 foot. So we take it from here. 171 is how many foot? 132, 11 foot. 171, how many foot? That's the question. So what we're gonna do is we're gonna get the calculator. 171.24 times 11 divided by 132.80. That's 14 feet 2 inches. That's your wall height. Wall facade, let's say. And this is also 16 inch. 14 feet 6, so I'm gonna take it. 16, 14 foot 6, and minus 13 too. Pick different green color for this one and apply here. Should I go to middle. Got up. Okay, now let's add the reinforcing. We're gonna adjust this reinforcing. That will cover at the top as well. Grade beam will come later. Okay, horizontal bars. Horizontal bars is number 5, 12 inch on center. Times 2. Horizontal each face. I'm gonna do horizontal bars again for the corner bars, and we forgot the corner bars on the other one. And times 2 is the regular each face, this U shape, L and L. Each face. I want to count. Actually, this one has only 2 corners. 1, 2. Actually, we can turn this way, and we can say 4. Because of each face, you'll say 8. Save. Now, let's count the corners on this guy, this wall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 corners for this. And this is gonna be horizontals. What was the horizontal on this? Number 5 again. U L times 2 and 13 corners. Corner bars, each face. 13 times 2, 26. Okay, so walls are done. Now we're gonna add the slab on grade and we'll be done with this foundation. As you can see, slab has the hunch. And what we figured for the hunch, let's figure that here. This was minus 12 foot 7.5. Okay, and then 5 inch slab thickness. So here I got 7 plus 5 is 12. So 13 feet 0.5 inch. And that's mean This is inch and a half. Hunch. Okay. Once we calculate that, we go here and we forgot about the columns. Alright, no problem. Let's do the slab on grade first. 5-inch slab on grade. Also, we need to add the information about the wire and vapor barrier. Wire mesh is reinforcing is the W2.9 to 2.96666. This is in the old version is 6666 WWF. On vapor barrier, I'm gonna say on vapor barrier, and we will add that later. Slab on grade. I have to look at the specs. What's the or architectures? Actually, I can look at now. Architectures maybe says it. Schedule finish. Two-inch rigid insulation outside with drainage board. This is waterproofing. We are not gonna include the rigid insulation. So since I see that, I'll show that exclusions. Rigid insulation. That covers everything. Alright, let's go back to this guy and see if we can see any detail here. 18307, those are the blowouts. 306 doesn't call. 307, not giving me anything about the slab. But I'm gonna take a look at this one also. Doesn't let me. I gotta finish this first. Actually, we're using the wrong tool. Copy. Okay, here typical slab detail. 6666 wire, vapor barrier. See, it says lab 12-inch, but it doesn't tell you the thickness. It doesn't tell you what kind of vapor barrier. So how you find it? You go to documents, specifications, individuals. Let's see. Instruction for bidders, divisions. Here you go. Right here, concrete. And you can basically search for vapor barrier. Maybe moisture barrier. It's gotta be in the materials. Carbon steel bars. Okay. Finishes, examination. Surprisingly, it doesn't tell you. I'm gonna search for mill. This is how they specify thickness, moisture, vapor. So it doesn't tell you. We're gonna just figure 10 mil vapor barrier. Okay, 5-inch slab on grade with 6666 WWF on 10 mil vapor barrier. 5-inch, and the top of slab elevation is minus 12 feet 7.5 inches. And get yellow for the slab. Let's tighten this up. And see, we use different sheet active. I'm supposed to activate this shit. No problem. We go inside the walls. There's a little bit of slab is not gonna go to outside of the wall, so into in. Alright, let's look at here. Now we got slab on grade as well. If you want to deduct for the elevated pit, that's okay. We can deduct here too, there too. Subgraph area. Okay. Now I want to add the hunches. Hunches, that's here. Another group for hunches. 1'6" by 2" thickness. We said we figured this out already. And the elevation is -12 plus 5" is the 13.5" minus 13 0.5", but that's top elevation, and the slab is 4,000 psi. I forgot to change on the other one, and this gonna go around like that. Yeah. Just continue, it's not a big deal. Couple inches here and there. This bit gotta go in today. And put that around here too. And the elevator. And we got it right. Now, what we missed, I don't see the piers. So we can do the piers. Here, 28 by 28 piers, minus 15 feet. And this was 2 inches like. And these piers are 13.2. There you go, this is typical. Let's add the piers. P 24 by 26. Rectangle. And the sideway is, we're gonna get 26. This is 24, 5,000. And the height we said 13.2 was our wall height. And 13.2. And the bottom will be minus 13 feet 2. Okay. And let's keep at this. You can turn them if you want to, but it's so close. I just want to use the same thing. Dimensions 24 by 26, 2" difference. You're not gonna see anything on the 3D. Here, what I'm gonna do is I'm gonna add 2 piers here because it's not giving me another. Hope I missed here. You can hide, for example, you can hide hunches to be able to see clearer. Okay, these are good. I got 2 more piers here, and I believe 28 by 20. Okay, let's do that different. Okay, just one thing, I gotta add new. Actually, we have peer group. We change the group. Now, This piece has 14 number 7, this has 16 number 7. What I'm gonna do is I'm gonna get that pier reinforcing, but this was double and vertical. These are high, just add new reinforcing. Let's start with the verticals. 16 number 7, 16 number 7. Z dimension is 0, Y is 0. Alright, we made a mistake on this. Let's see. Okay, yes. What was it? 26 by 24, 2 foot. We forgot to. I thought I did 13 feet 2. Okay, now it's better. Z, everything works. Okay, Z. And we add in 16 number 7, 13 2. These are verticals. And then again Z for the dowels. Same reinforcing. Shape is different. And this will be 4 foot and 1 foot 6, 5 foot 6. Adding footing thickness to lap splice, 5 foot 6, 5 foot 7. I'll call this 6 feet. Dowels. And number 4, 12 inch on center for the hull. A lot of phone calls. Alright, let's see what we left of it. Alright, we're gonna add ties to this pier. So for the ties ranges, this number 4 ties Z, and then select the tie shape, just pressing T, keep pressing A, and that's about it. This is ties. Now we copy this reinforcing and we can add to this one. First create this. Where's this piers are here? Okay. Now this pier 28 by 28. It's a square, 28 inches, and the height is 13 feet 2. Bottom is 13 minus 13 2. 5,000 psi. Boom, boom, and add paste the rebar from the other one. Basically, we're done. Now we got all the piers, and our building is ready. Couple minor things we need to add. Okay, this pier was low, so 1270 17.6 F5 was what? F5 is 2 foot 6. So top of this pier is minus 15. 12 foot 6 to minus 15, 2 foot 6 pier here. Let's add this pier as well. 28 by 28. 2 foot 6 is the difference height. I'll call this 3 feet, and the top is minus 15. I cannot paste in this one because this is too short. Let's say 16 number 7. This one is 16 number 7, and this one has 16 number 7. Yeah, same reinforcement. Actually, I can. I'm just gonna change those verticals, remove verticals, change those to dowel and vertical. So 2 foot 6 is the footing and a 4 foot is the left. Now 3 feet is the Z direction and 2 foot 6, 5 foot 6 here. 2 foot 6 the depth of the footing and 3 feet the height of the pier. That's what it gives us. This is the standard hook. And the ties are just 4 ties. That's it. Now we are not doing the rigid insulation because it's for the waterproofer. And all I need to add is base plates for this column footings. Alright, so these are at the 0 elevation and the interior ones at the -12. These are at the top of the wall and the top of pier. What I'm gonna do is create base plates. We need to install anchor bolts and base plates. I'll do black. 1 foot thickness is 1 inch. It's not a concrete item. And the bottom elevation is 0. That means it sits on top of these walls. And I just need to pick the count on this. I need the cubic yard as a formula. And I'll go here and click on this. You know, all the piers gets 1 base plate, a set of anchor bolts. Okay, now interior ones, what I'm gonna do is I'm gonna change the elevation on 1 to bottom elevation minus 12 foot 7.5 inch. And I'm gonna copy this one so I don't have to change the elevation on the others. It copies together with the elevation in it. So let's refresh here. It was actually showing already. See, you can see the base plates, the black squares, and here. Did I miss on this one? Something wrong with this pier. Okay, now it's there. Just not showing. Okay. Alright, I need to put 4 more base plates. Where are these base plates? I gotta create another group. Miscellaneous. And add 4 more base plates. And we're basically done. Let's see. So our foundation bit has 555 cubic yards and 67,000, almost 68,000 of the rebar. Now I'm gonna proceed. I'm gonna check this if the formulas are good. And 1 is missing here. We don't know why. There's a bug probably. And I have to keep continuing the slab on deck and side concrete, and I have to finish this. I'm stopping the video here, and I see you guys in the next video. Thank you.